In this module, we shall study about the portfolio, risk and return. What is portfolio? Portfolio means a set or combination of different financial assets or securities held at a point of time for the purpose of investment and not for consumption purposes. These financial assets or securities may include shares, debentures, bonds, government securities, etc. Different portfolios are designed according to the investor's risk tolerance, time frame and investment objectives. Why portfolio? Investors aim at maximizing their returns or minimizing their risk. Different securities carry different degrees of risk. In an attempt to spread their risk, most investors tend to hold more than one security. Constructing a portfolio or combination of securities helps to spread risk over many securities. After studying this module, you shall be able to know the meaning of portfolio, understand the portfolio principles of diversification and negative correlation, measure the return and risk of portfolio, analyze the effects of combing securities. We shall now discuss the principles of portfolio. A portfolio is constructed for achieving maximum returns with minimum risk. The fundamental principles, also called as notion of portfolio, which are universally applicable and followed in the creation of portfolio for either maximization of returns or minimization of risk, are given as follows. Diversification. Diversification means that a portfolio must contain large number of securities across different firms and industry lines which could be easily managed. It is strategy of holding more than one security type in a portfolio for minimizing risk. Generally, a portfolio of 15 to 20 securities is considered as manageable. This helps in reducing the non-systematic risk of the portfolio, as poor performance of one security can be offset by the better performance of another. This is called not keeping all eggs in one basket. Negative correlation. Negative correlation means that a change in one variable is inversely related to the changes in other variable. The notion of negative correlation denotes that as far as possible, the securities included in a portfolio should be negatively correlated. It is hedging strategy for risk. The securities with negative correlation also serve the purpose of diversification. This helps in minimizing the total risk of the portfolio. A perfect negative portfolio among the securities in a portfolio reduces the portfolio risk to zero. Let us now understand the portfolio return and risk. Portfolio analysis is based on the expected future return and risk of holding different combinations of individual securities. Thus, we need to calculate portfolio return and portfolio risk for analyzing the portfolio. Portfolio analysis has been classified: first, expected return of a portfolio; second, portfolio risk. Next, expected return of a portfolio. The expected return on a portfolio is nothing but simply the weighted average of the expected returns of the individual securities in the given portfolio. The return on a portfolio is given by the formula capital E RP is equal to summation I is equal to 1 till n Wi into capital E Ri, where capital E RP is equal to the expected rate of return on the portfolio, Wi is equal to the weight of the security I in the portfolio, capital E Ri is equal to the expected rate of return of the security I, n is equal to number of securities in a portfolio. Here, weight of the security is the proportion of portfolio value in that individual security, and combined portfolio weight is equal to 1. Summation I is equal to 1 till n Wi is equal to 1. Example: Suppose a portfolio consists of 3 securities A, B and C with expected returns of 12%, 15% and 18% respectively. The proportion of total investment in these securities are 0.30, 0.40 and 0.30 respectively. Find the expected return on the portfolio. Here WA is equal to 0.30, capital E RA is equal to 12%, WB is equal to 0.40, capital E RB is equal to 15%, WC is equal to 0.30, capital E RC is equal to 18%. Putting into the formula we have capital E RP is equal to WA into capital E RA plus WB into capital E RB plus WC into capital E RC. Putting the values, which is equal to 0.30 into 0.12 plus 0.40 into 0.15 plus 0.30 into 0.18, which gives you 0.15, which is equal to 15%. Therefore, the expected rate of return of the given portfolio of 3 securities is 15%. Now, suppose a fourth scrip D is included in the portfolio by partly selling the earlier investment in B, say about 20% of the total investment. The expected return from D is 20% during the same holding period. Then the expected return of portfolio of 4 securities is calculated as follows. Capital E RP is equal to 0.30 into 0.12 plus 0.20 into 0.15 plus 0.30 into 0.18 plus 0.20 into 0.20, which is equal to 0.036 plus 0.03 plus 0.054 plus 0.04. Total 0.16 equal to 16%. Next, portfolio risk. The risk of the individual assets securities is estimated through standard deviation or variance. The portfolio risk is calculated using the risk of individual assets, weights of the assets in the portfolio and either correlation between the assets or covariance of the assets return. Next, covariance. Portfolio risk can be calculated by considering the interactive risk or covariance. Covariance shows the extent to which the returns of 2 securities vary or move together. A positive covariance implies that the rates of return of 2 securities move in the same direction and vice versa. Zero value of covariance shows the rate of return are independent to each other. Mathematically, covariance is given by the formula. Covariance xy is equal to 1 upon n summation I is equal to 1 till n rx minus rx bar into ry minus ry bar, where the probabilities are equal and covariance xy is equal to covariance between x and y, rx is equal to return on security x, ry is equal to return on security y, rx bar is equal to expected return on security x, ry bar is equal to expected return on security y and number of observations. Next, correlation. The coefficient of correlation is another measure to reflect the degree of co-movement between 2 variables. The correlation between 2 securities depends upon the covariance between 2 securities and the standard deviation of each security. Mathematically, we define correlation as Rxy is equal to covariance xy upon sigma x into sigma y, where Rxy is equal to coefficient of correlation between x and y, covariance x and y is equal to covariance between x and y, sigma x is equal to standard deviation of x, sigma y is equal to standard deviation of y. The value of coefficient of correlation between 2 variables lies between -1 and +1. The correlation coefficient of -1 between 2 securities implies a perfect negative correlation between the securities. A zero correlation coefficient means that the securities are independent of each other, and +1 implies that there exists a perfect positive correlation among the securities. Next, calculation of portfolio risk. Now we learn to calculate portfolio risk. Portfolio risk in a two security case is given by the formula sigma p square is equal to w1 square into sigma 1 square plus w2 square into sigma 2 square plus 2 into w1 into w2 into p12 into sigma 1 into sigma 2 where sigma p square is equal to variance of portfolio return, w1, w2, weights of securities 1 and 2 respectively, sigma 1, sigma 2, standard deviation of the returns on security 1 and 2 respectively, P12 sigma 1 into sigma 2, covariance of the return on securities 1 and 2. Thus, the portfolio risk in a case of two securities is the sum of weighted variance of two securities plus twice the weighted covariance between two securities. Next, portfolio risk in n security case is given by the formula sigma p square is equal to double summation wi into wj into pij into sigma I into sigma j, where sigma p square is equal to variance of portfolio return, wi, wj is equal to proportion of portfolio investment in security I and j respectively, pij is equal to coefficient of correlation between the return on security I and j, sigma I, sigma j is equal to standard deviation of the return on security I and j respectively. Moving on to the effect of combining securities. As a matter of fact, holding two securities together is less risky than holding either of the securities alone. But does investing a part of the money in a security that is riskier than any of the securities held initially would help in reducing the portfolio risk? We try to find answer to this from the following example. Given two stocks X and Y, where Y is considerably riskier than X, a portfolio of securities X and Y may be less risky than a portfolio consisting exclusively of the less risky asset X. Assume the following about stock X and Y in table. Stock X and stock Y. Return in percentage, stock X 8 or 12%, stock Y 14 or 6%. Probability 0.5 each return, for Y 0.5 each return. Expected return in percentage 10 for X and 10 for Y. Variance in percentage 4 for X, 16 for Y. Standard deviation in percentage 2 for X and 4 for Y. Expected return is equal to X is equal to 0.5 into 8 plus 0.5 into 12 which is 10. Y it is 0.5 into 40 plus 0.5 into 6 which will give you 10. It is clear that though both X and Y have the same expected return, that is 10%, Y is riskier than X, standard deviation of 4 versus 2. Further consider that when X return is high, Y return is low and vice versa. Question: is it possible that a portfolio of X and Y be less risky than exclusively holding the lesser risky stock X? To check, we construct a portfolio of 2/3 stock of X and 1/3 stock of Y. The expected average return of the portfolio is given by the formula Rp is equal to summation of I is equal to 1 till n Wi into Ri, where Rp is equal to expected return on portfolio, Wi is equal to proportion of total portfolio invested in security I, Ri is equal to expected return on security I, n is equal to total number of securities in an portfolio. Therefore, Rp is equal to 2 upon 3 into 10 plus 1 upon 3 into 10 which is equal to 10. In periods when X return is low, Rp is equal to 2 upon 3 into 8 plus 1 upon 3 into 14 is equal to 10, and similarly when X return is high, Rp is equal to 2 upon 3 into 12 plus 1 upon 3 into 6 which is again equal to 10. Investing exclusively in security X alone we get return as high as 12% and as low as 8% with a standard deviation of 2%. Whereas holding a security of 2/3 of x and 1/3 of y, we can always expect a return of 10% with standard deviation 0. Thus, we are able to reduce risk considerably by investing a part of money into the riskier stock Y. Here, it becomes important to know the interactive risk among the securities apart from knowing the riskiness of individual securities. For this type of risk hedging, we need to find two securities which behave in an inverse manner and are negatively correlated to each other. Let us now recapitulate what we have learnt so far. Portfolio is a combination of securities held for the purpose of investment. Holding a portfolio of securities is preferred over holding a single security as it spreads the risk among different securities of the portfolio. Diversification and negative correlation are the two fundamental notions of portfolio construction that help in reducing the risk of the portfolio. Portfolio return is just the weighted average of the expected returns of the individual securities in a portfolio. Mathematically, capital ERP is equal to summation I is equal to 1 till n Wi into capital ERI. Unlike portfolio return, portfolio risk is not the weighted average of the standard deviation of individual securities. We need to find the interactive risk, that is covariance, and the correlation between securities for the measurement of portfolio risk. Correlation and covariance show the extent to which the returns of two securities vary or move together. Mathematically, their relationship is expressed as follows. Rxy is equal to covariance xy upon sigma x into sigma y. The coefficient of correlation lies between -1 and +1. Portfolio risk in two security case, sigma p square is equal to w1 square into sigma 1 square plus w2 square plus sigma 2 square plus 2 into w1 into w2, covariance between 1 and 2. Sigma p square is equal to w1 square into sigma 1 square plus w2 square into sigma 2 square plus 2 into w1 into w2 into rxy into sigma 1 into sigma 2. Portfolio risk in n security case, sigma p square is equal to double summation wi into wj into rij into sigma I into sigma j. The risk of a portfolio can be reduced by investing a part of money in the more risky asset rather than holding a portfolio exclusively consisting of the less risky asset only. Thank you.